Hello everyone. Today we're going to look at usaco-training magic squares. In this problem we're given some magic squares, which means it has a sheet composed of 8 equally sized squares. So as you can see here, we have 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so each square would have a different color, and then they would be donated by the first 8 positive integers. So then over here, this would be basically a permutation of 1 to 8. Okay, so then we have 3 types of transformations labeled A, B, and C. The first one, A, exchanges the top row and the bottom row. So as you can see here, if this was our original transformation, then if we swap the top row and the bottom row, we would get 8, 7, 6, 5, 4, 3, 2, 1. And over here, for B, it's basically a single right circular shifting of the rectangle. So what happens is that 1 over here would get moved over here. So you can basically imagine it as a chain or something. And then if you rotate it, then basically as it says over here, every cell would move 1 to the right. So then 1 would go over here, 2 would go over here, 3 would go over here, and 4 would and basically since you would move right, then the 4 would basically come back to the same side, resulting in over here. Okay, for C, it's a single clockwise rotation of the middle 4 squares. So if we have if this is our original configuration, then after we transform it, you know that the 1, 8, 4, and 5 would stay the same, since they're only changing the 4 middle squares. And then since they're making a clockwise rotation, the rest would become 7, 2, 3, and 6. Alright, so we're going to determine the minimum sequence of these transformations to transform our initial configuration to our target configuration. Okay, so this is basically our target configurations. So it's just going to be 8 integers, and then our output is first going to be the length of the number of transformations we're going to have to apply. And the second line is basically the type of transformations that we're going to apply. Alright. So over here, we can basically give this as, let's call this 1, 2, 3, 4, 5, 6, 7, 8. Okay. So notice that this can basically be our index of our configuration. So as in the input, we know that if we put A, this would result in 8, 7, 6, 5, 4, 3, 2, 1. If we do B, then we would get, since we would basically rotate it, so this would become 4, 1, 2, 3, 5, 8, 7, 6. And if we apply C here, we would get 1, 7, 2, 4, 5, 3, 6, 8. Okay, so now that we know this is how we do our transformations, what we can do is that we can use a Q for this. Q-U-E. Okay, so what a Q does is that we can use this to make a breadth first search, where we start off at our initial configuration, which is going to be 1, 2, 3, 4, 5, 6, 7, 8. So now, if we know that this is our start, if we first push this into our queue and then we start searching from that point, every time we encounter a new node, we know that is going to be the minimum number of moves to make that. So then it would basically look like this. Let's call this our queue go to cube. So then we would first insert our start. So now after this, we're going to keep on doing this. So we're going to basically while Q is not empty. So Q is not empty. Let's call this our state. So let's call this equal our first element. So we know that this is our state, and then we're going to try to apply these three types of transformations. So we're going to try applying A, B, and C. Okay. So basically, let's just say we apply A. So after we apply this, we're going to get a new state. Okay, so let's call this next. Oops. Next will be equal to, let's just say, apply A, and we have our state. Okay, so we know that this may be our next state, and then what we're going to do next is that since you know your next state, and basically what happens is that if you already visited your next state in your breadth first search, then you know that you would not want to search it before, because let me actually write it down. So the thing is that breadth first search, let's just call this BFS. This basically extracts the basically the minimum distance. In this case, this is going to be the minimum number of transformations we're going to make. So then, basically, if visited next, we're not going to do this. So we can just or basically if this is equal to false, which means that we did not visit this before, then we can insert our next state. And then we can also try applying B, or we can also try applying C. And what happens here is that this would basically extract the lexicographically first one, because what happens is that we first insert A, and then we insert B, and then we insert C. So every time we know that, since we know that A is less than B and B is also less than C, then if we insert A first, then this would result in the lexicographically ordering first one. So now we know that our state here, so when do we actually stop? So what happens is that over here, basically we know that this is our current state. So then basically we can insert this over here. So if state is equal to our target, then we know that we're done here. So if it's equal to our target, then we can just break here, and we know that our answer is going to be the number of rows. So actually implementing this in during coding is going to be more complicated, because not only are you going to keep track of the state, you're also going to keep track of which transformations you used and the number of moves you used as well. And basically, let's talk about applying these three transformations. So you know that this is our start configuration. We can basically write this as an array. So this would be 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now let's just say we're applying A. Okay, so basically we know this again is basically equal to over here, so this would also be a 1, 2, 3, 4, 5, 6, 7, and 8. So over here, this would become 8, 7, 6, 5, 4, 3, 2, 1. So you may notice that what happens here is that you're basically just reading over here, and then you're just coming back. So you can basically generate the array configuration. So this would again become 4, 1, 2, 3, 5. Actually this would be 6, 7, 8, 5. So then this would be a lot more easier, because what you notice is that 8, this would actually correspond with the item at the 8th position. So this would actually be position. And then to generate our next one, we will just get the value of that specific position. Okay, so let's get coding. Alright, so let's suck that. So let's include bits. Alright. So we're going to have our goal configuration. We can actually store this in a string. So let's call this goal. Alright, make sure we have that as well. So we can just read our goal over here in our case. Or actually, never mind. So we're actually going to have 8 elements. Alright, so then we're going to have here, so you're going to have an integer since from 1 to 8. So let's just read x, and we will just add a character of 0 plus x. Or actually, this would be 0 plus x minus 0. Alright. Whoops. Alright, so now that we have our goal, remember that we're going to have our state. So then, let's have, our state can actually be a string, which is going to be represented by using like basically 8 characters of a string. So we can have a queue of string. This is going to be our queue. So this is, and then at first we're going to insert our starting state, which is going to be 1, 2, 3, 4, 5, 6, 7, 8. Alright. So after this, we're going to do this while your queue isn't empty. So let's call this our state, or let's call this x is going to be our first element in our queue. We're going to pop it, or yeah, this is actually push, not insert. Alright, so I said that we're basically going to check that if this is equal to our goal, and if it is, then we basically know that we're done. So basically, if x is equal to our goal, then we can break. Because if we already reached our goal, we don't have to keep on searching. So now we need to keep track of a few more things. So let's call this map string. This is going to be our basically our configuration. And what this is going to store is that, for example, you see over here that, or let's actually go to the problem. So basically, to make this, we're going to have our specifically our configuration of transformations that we're going to apply. So this is going to be B, C, A, B, C, C, B. So then, this is whatever we're going to store here is going to correspond what we store in our configuration. Okay, so basically, that's going to be that. And then we're going to basically, again, have a visited set. So let's call it visited. Alright. So what we're going to do here is that we're going to set visited. We're just going to insert our string. Alright. So now we're going to try to apply A. Okay, so we can call this our next. So let's call this apply A. Okay, so our next will be equal to, let's set this equal to x. And actually, if you notice here, this would be equal to 8, 7, 6, 5, 4, 3, 2, 1. And what happens is that over here, this is actually this thing, but reversed. So then we can actually just apply a function. So then our next, we would just reverse it. So reverse next dot begin, next dot end. So after we reverse it, we're going to do basically if visited dot find next is not equal to visited.n, or basically if this is equal to visited.n, then it means that we can basically insert this. So then visited, yeah, so I misspelled that. We're going to insert this, and then we're going to set our configuration. And next will be equal to configuration of x plus a. And then we're going to push this into our queue. So originally we can set configuration of this equal to 0. Okay, so now we're going to apply b. And let me just copy the array down. So we have 4, 1, 2, 3, 6, 7, 8, 5. And this is basically one index. And since we want to use 0 indexing, so then we would basically subtract 1 from each of these, so this would become 3, 0, 1, 2, 5, 6, 7, 4. So this would be 1 indexed. So then our next would be equal to, we basically construct this, so this would be equal to x of 3 plus x of 0 plus x of 1 plus x of 2, x of 5, x6, x7, x4. So again, we're going to check. As I said, we're going to use like similar things. Oh, okay, so interesting. So what you're going to do here is that since this is a character, then you're actually not allowed to basically construct this. So what you can do is that let's have let's get this string get. So we're going to get this from a character. So we're just going to return string 1c. Okay, so over here, oh yeah, so this should be equal to nothing, by the way. And over here, this should be get 3, get 0, get that. Okay. Alright, so over here, instead of adding A, we're going to add B. Alright, so now after this, we're going to try applying C. So this is going to be 1, 7, 2, 4, 5, 3, 6, 8, and this is again going to be 1 indexed. So we're going to make the 0 index, so this is going to be 0, 6, 1, 3, 4, 2, 5, 7. So then, to do here is then next would be equal to get x0, get x6, get x1, get x3, get x4, get x2, get x5, and get x7. So again, we're going to try inserting this into our queue. So instead of putting B, we're going to put C. Okay, so now after we insert it, we would basically reach our goal one time. So after we reach it, we would break, and then we're going to, okay, so we actually have to keep track of one more thing, which is going to be basically the distance. And we actually do not have to keep track of that because that is just going to be the size of our configuration here. So then after this, we're going to print configuration of goal.size. And then we're going to print the configuration. So let's try running this. Okay, this should actually be configuration. Alright, so let's run it. 7 BCA BCCB. So that looks good. Okay, so then we have to read from ms_squared.in reopen Alright, so I'm just going to include cn.tie 0. So what this does is that this basically speeds up the input and output a lot faster because it unsyncs the functions from the C input and output functions. So then over here, let's just run this. So this is going to be, this is ms square, magic square. Alright, so let's go here. Oh, okay, so I just read this. So it says that we basically want only 60 characters per line. So then we can, this is actually going to be a bit more complicated because we're going to have to print it character by character. So then we can call this C, which is going to be the number of characters we printed. So basically for each character, C in configuration goal, let's actually call this CH. So we're going to print CH and we're going to increment our C. So if C is equal to 60, meaning that we printed 60 characters, we're going to reset it and we're going to print a new line. And if C is not equal to 60, meaning that we did not just set it equal to a new line, or this should actually be 0. Alright, we're going to print a new line here. Alright, so over here, let me select the file. Alright, so other. Alright, let's submit it. Ooh, okay. The correct answer length is 3. Oh, okay. So it looks like I did print an extra new line. So then, because we actually set it to 0 over here. So let's actually just set that as another case, because what happens is that it doesn't want us to print an extra new line. So basically if configuration goal dot size, if it has stuff in it, then we're going to print this stuff as well. Alright, so let's go submit it. Okay. Ooh, so it wants us to print a new one. Okay, so if there's this, then otherwise, we're going to print a new line here. Alright, that's just a bit confusing, but we're just gonna have to deal with it. Ooh, okay, so that is correct. If you have any questions, feel free to leave them in the comment section below. Thank you. Bye.